Good morning, children. Today we are going to see the new topic, directs and cosines, directs and ratios, and the directs and angles. First, we need the basic. Listen, we know that in two dimensions. Listen, y-axis, x-axis. Listen, x-axis, y-axis, which is a two dimension. Let O be the origin. So, which is in a two dimension. Now, today we are going to see three dimension. Three dimension means, say you want to think this object. Listen, here, listen, it is x-axis, x-axis, y-axis, y-axis, and z-axis. So we want to think this object in the space x-axis, y-axis, z-axis, where x-axis, y-axis, z-axis are perpendicular to each other. Perpendicular to each other. Listen, in three dimension, see, which is z-axis, y-axis, and x-axis. Listen, x-axis, y-axis, and it is z-axis. Let O be the origin. Here, these three axes are perpendicular to each other. And for your understanding, listen, for your understanding, first let us draw the cube. Yes, which is a square, and above the square draw one more square with the equal size. With the equal size. Now join the edges. Okay, join the edges. Join the edges. Now let O be the origin. Now extend downwards, which is x-axis, and extend this edge to rightward, which is y-axis. Extend this edge to upwards, which is z-axis. So x-axis, y-axis, z-axis are perpendicular to each other. So we are going to see which is a three-dimensional figure. Listen, we want to think this object in three-dimensional space. So we are going to see today three-dimensional. Children, listen. Today our topic is directs and cosines, directs and ratios, and the directs and angles. Listen, directs and cosines. Directs and cosines. Directs and cosines, come on. Directs and ratios. Directs and ratios, and directs and angles. Directs and angles. So, which is the today topic? You see, directs and cosines, directs and ratios, and the directs and angles. And we are going to study these three topics in three-dimensional space. Listen, first z-axis, say y-axis, and x-axis. So x-axis, y-axis, z-axis. Let O be the origin. Let O be the origin. Now, along x-axis, let the unit vector is I cap. Along x-axis, let the unit vector is I cap. Along y-axis, let the unit vector is j cap. J cap. Along z-axis, let the unit vector is k cap. Now, let I cap, j cap, k cap are the unit vectors along x, y, z axis respectively. That's all. And here I vector, j vector, k vector are perpendicular to each other, or the unit vectors are perpendicular to each other, because already x-axis, y-axis, z-axis are perpendicular to each other. Therefore, let I cap, j cap, k cap are perpendicular unit vectors to each other. Now, let P is a point of, listen, let P is a point of x, y, z in the space. Let P is a point of x, y, z lies in the space, and whose distance from the origin is small r. Whose distance is r. And here OP vector is equal to, let OP vector is equal to R vector. Let OP vector is equal to R vector, and the distance from the origin to the point P is equal to small r. Okay. And let capital R, listen, let the capital R and capital S and capital T. Capital T. Let R, comma, S, comma, T are the perpendiculars drawn from the point P to x-axis, y-axis and z-axis respectively. Let R, S, T are the foot of the perpendiculars drawn from the point P to x-axis, y-axis, z-axis respectively. Okay. Now let the measurement of angle. Let the measurement of angle POR is equal to alpha. Let the measurement of angle POR is equal to alpha. Let the measurement of angle POS is equal to beta. Next, measurement of angle POT is equal to gamma. So which is gamma? Now listen again. Let the measurement of angle POR is equal to alpha. Let the measurement of angle POS is equal to beta. Let the measurement of angle POT is equal to gamma, where alpha, beta, gamma are the direction angles. Okay, one concept is ready. Now let us write the theory portion. Listen, let O be the origin. Let O be the origin. Let O be the origin. Let I cap, j cap, k cap are the perpendicular unit vectors along x-axis, y-axis, z-axis respectively. So next point is let I cap, j cap, k cap are the unit vectors. Are the unit vectors along x-axis, x, y, z axis respectively. Let I cap, j cap, k cap are the unit vectors along x, y, z axis respectively. Unit vectors along x, y, z axis respectively. Okay. Next. Here, let P is a point. Let P is a point of x, y, z on the space. Let P is a point of. Let P is a point of x, y, z. Let P is a point of x, y, z be a point. Be a point on the space. Be a point on the space. Clearly, where say P is a point of x, y, z means where x denotes x coordinate distance. That is the distance OR. The distance OR is equal to x. And the distance OS is equal to y. And the distance OZ, that is OT is equal to z. Again, say x, y, z means where x is the x coordinate distance. So OR is equal to x. Next, OS is equal to y. And OT is equal to z. So which is the concept. Next, here OR vector is equal to x into I vector, because say magnitude is equal to x and its direction vector is I vector, I cap. Children listen. Next point, let R, S, T be the perpendiculars drawn from the point P. Okay, listen. Next step, let R, S, T are the perpendiculars. Are the perpendiculars. Are the perpendiculars drawn from the point. Drawn from the point. Drawn from the point. Drawn from the point P to x, y, z axis respectively. Okay. Now listen. the distance OR equal to x, magnitude is equal to x, OS equal to y, OT is equal to z. Now let OR equal to x, comma, OS is equal to y, comma, OT is equal to z. Okay. Therefore, the position vector of P with respect to origin O is given by OP vector. OP vector is equal to R vector. OP vector is equal to R vector. Now, here OP vector is equal to R vector is equal to. OP vector is equal to R vector is equal to, here magnitude x along this direction I vector. Therefore, x into I vector plus magnitude y and its direction vector is, yes, j vector. Therefore, y into j vector plus magnitude z and its direction vector is k cap. Therefore, z into k cap. Therefore, OP vector is equal to x into I cap. That is x into I cap. OP vector is equal to R vector is equal to x into I cap plus y into j cap plus z into k cap. So OP vector equal to R vector is equal to x into I cap plus y into j cap plus z into k cap. Okay. Now let us find the magnitude of this vector. Okay. Any idea to find it? Very good. That is modulus OP vector. Modulus OP vector is equal to modulus R vector is equal to, where we know that modulus R vector equal to, what is the modulus R vector? Yes, magnitude of R vector equal to R. So one can write simply R, that is modulus R vector equal to R. Similarly, modulus OP vector equal to OP. So modulus OP vector equal to OP, modulus R vector is equal to R, which is equal to, that is modulus R vector is equal to square root of sum of the squares of I, j, k coefficients. That is, here I cap coefficient x, therefore x square, square root of x square, plus here j cap coefficient y, so plus y square, plus k cap coefficient is z, so plus z square, which is magnitude of R vector. Magnitude of R vector is given by modulus R vector, which is equal to R, is equal to square root of sum of the squares of I, j, k coefficients. Okay. See, for example, suppose let OP vector is equal to R vector is equal to I vector plus 2j vector plus 3k vector. And therefore, modulus OP vector equal to modulus R vector is equal to R equal to square root of, can you tell me? Yes, because see I cap plus 2j cap plus 3k cap. Therefore, modulus R vector equal to R equal to square root of, here I cap coefficient, we are considering I cap coefficient 1, j cap coefficient 2 and k cap coefficient 3, for example. Therefore, 1 the whole square plus 2 the whole square plus 3 the whole square. Likewise, you want to find. Okay, modulus R vector is ready. And next step, here again come to the diagram. So here measurement of angle POR is equal to alpha, POS is equal to beta, then POT is equal to gamma. Now listen, measurement of angle POR is equal to alpha, POR is equal to alpha, comma, measurement of angle POS is equal to beta, comma, measurement of angle POT is equal to gamma. Therefore, alpha comma beta comma gamma are the direction angles. Therefore, alpha comma beta comma gamma are the direction angles. Are the direction angles. Okay, one concept is ready. Listen, we are going to study 3 topics: direction cosines, direction ratios, direction angles, where alpha comma beta comma gamma are the direction angles. Okay, and then next concept is we want to consider direction ratios. Here x comma y comma z are the direction ratios. Listen, x comma y comma z are the direction ratios. X comma y comma z are the direction ratios. direction ratios. Direction ratios. Okay. And also here already we told r comma s comma t are the perpendiculars drawn from the point P. And in this diagram it is difficult to understand. You want to think in three dimensional. In three dimensional, let P be a point on the space, and r comma s comma t are the perpendiculars drawn from the point P. So from in this diagram it is difficult to understand, but you want to think the object in the three-dimensional space. Therefore, here r, s, t are the perpendiculars drawn from the point P. Therefore, measurement of angle P or O is equal to 90 degree. Measurement of angle. Measurement of angle P or O is equal to 90 degree, which is equal to, similarly, measurement of angle PSO equal to 90 degree, and the measurement of angle PTO is equal to 90 degree, which means measurement of angle PRO equal to 90 degree, measurement of angle PSO equal to 90 degree. Similarly, yes, measurement of angle PTO is equal to 90 degree. Okay. Now, let us consider the triangle that is POR. Let us consider the triangle POR, which is a right angled triangle in which POR. Can you tell me what is measurement of angle R? Yes, very good. Measurement of angle R is equal to 90 degree. It is 90 degree. Yes. And measurement of angle POR is equal to POR. Measurement of angle POR is equal to alpha. So measurement of angle POR is equal to alpha. Okay. What is the distance OR? Very good. X. The distance OR is equal to X. Okay. Next, the distance OP is equal to R, because OP vector is equal to R vector and the magnitude of R vector is equal to R. The distance OP is equal to R. The distance OP is equal to R. Okay. Now listen. Here it is angle alpha. Alpha opposite? Yes, very good. Which is opposite side. Opposite side. See, alpha angle opposite side, that is PR is equal to opposite side. Next, it is 90 degree. Can you tell me what is 90 degree opposite? Yes, hypotenuse side. 90 degree opposite hypotenuse side. It is hypotenuse side. Okay. Say alpha angle opposite side. 90 degree opposite hypotenuse side, and one side is remaining. Can you tell me what is remaining side? Yes, very good. Which is adjacent side. It is adjacent side. Okay. Now, here adjacent side is equal to X and hypotenuse side is equal to R. Opposite side is unknown. Okay. Here adjacent side and hypotenuse side are known. Can you tell me which ratio connects adjacent side and hypotenuse side? Yes, very good. Cos. That is, here angle is alpha, cos alpha. Therefore, cos alpha is equal to adjacent side by hypotenuse side. Adjacent side is equal to OR. Adjacent side is equal to OR divided by hypotenuse side equal to, yes, OP. Okay. Which is equal to, what is OR? Good. OR equal to X divided by OP, where OP is equal to R. Therefore, see this in, let us consider first and last. Therefore, cos alpha is equal to X by R. Cos alpha is equal to X by R. Similarly, cos beta is equal to, yes, Y by R. Cos gamma is equal to, good, Z by R. So similarly, cos beta is equal to Y by R, and cos gamma. Cos gamma is equal to Z by R. Listen, we know that cos alpha is equal to X by R, comma, cos beta is equal to Y by R, comma, cos gamma equal to, yes, Z by R. Therefore, the direction cosines are cos alpha, comma, cos beta, comma, cos gamma. So the direction cosines are cos alpha, comma, cos beta, comma, cos gamma, which is equal to Okay, what is cos alpha, comma cos beta, comma cos gamma? Yes, cos alpha is equal to x by r, comma. Yes, cos beta is equal to y by r, comma. Cos gamma equal to, yes, z by r. Okay, so direction cosines are cos alpha, comma cos beta, comma cos gamma is equal to x by r, comma y by r, comma z by r. Okay, and the next step, direction ratios. Direction ratios. Okay, the direction ratios are, can you tell me what is the direction ratios? Yes, x comma y comma z, because OP vector equal to r vector is equal to xi vector plus yj vector plus zk vector. Therefore, the coefficients of ijk are said to be direction ratios. So direction ratios are x comma y comma z. And we have infinite number of direction ratios because where x is the distance from O to R, and the distance may be going to change. Therefore, x comma y comma z comma suppose kx comma ky comma kz, where k is some constant, etc. also the direction ratios. Okay, here simply direction ratios are x comma y comma z. Okay, direction cosines, direction ratios, and already we know that direction angles are alpha comma beta comma gamma. So these are the three topics. Okay, now next step, listen, suppose cos square alpha plus cos square beta plus cos square gamma. Okay, which is equal to, see, let us find sum of the squares of the direction cosines. So cos square alpha plus cos square beta plus cos square gamma means sum of the squares of the direction cosines, which is equal to, can you tell me what is the cos alpha? Yes, cos alpha equal to x by r, but I need cos square alpha. What is cos square alpha? Cos square alpha equal to, good, x square by r square. So cos square alpha is equal to x square by r square plus cos square beta equal to, good, cos beta equal to y by r. Therefore cos square beta equal to y square by r square. Y square by r square plus cos square gamma. Cos gamma equal to, good, z by r. Cos square gamma equal to, very good, z square by r square. Z square by r square. Okay, which is equal to, now simplification yourself. Yes, r square is LCM. That because divided by r square, divided by r square, divided by r square. So r square is LCM. Okay, now 1 time of r square, 1 time of r square. So 1 into x square is equal to x square. Good. Next step is similarly y square plus z square. Okay, which is equal to, what is x square plus y square plus z square? Yes, we know that already, that is r is equal to square root of x square plus y square plus z square. Okay, that is modulus r vector is equal to r equal to square root of x square plus y square plus z square. But I need x square plus y square plus z square, no need this square root. Okay, how to eliminate this root? Good, squaring on both sides. Squaring on both sides, which is a rough work. Squaring on both sides, r square equal to, squaring on both sides means r square equal to root cancel. While squaring, the square root cancel. So r square equal to x square plus y square plus z square. Okay, come to the numerator. What is numerator? Good, where numerator equal to r square. So r square divided by r square, which is equal to 1. Because 1 time of r square, 1 time of r square cancel. 1 by 1 is equal to 1. What is LHS? Yes, LHS is equal to cos square alpha plus cos square beta plus cos square gamma. Cos square gamma. So which is the result 1. Listen, sum of the squares of the direction cosines is equal to 1. So which is one result. Similarly, we can derive one more result. Let us find a sin square alpha plus sin square beta plus sin square gamma, which is equal to. Any idea to simplify? Yes, very good. Sin square alpha is equal to 1 minus cos square alpha. So sin square alpha is equal to 1 minus cos square alpha plus similarly sin square beta is equal to, yes, 1 minus sin square beta is equal to 1 minus cos square beta. plus sine square gamma equal to, good, sine square gamma equal to 1 minus cos square gamma. 1 minus cos square gamma. Okay, now simplification yourself. Any idea? Good. 1 plus 1 equal to 3. So 3 minus of, here minus, where minus common. What is remaining? Yes, remaining cos square alpha. Okay, if I doubt, minus into cos square alpha minus cos square alpha. Okay, similarly 2 more times. Good. So plus cos square beta plus cos square gamma. Okay, verification please. Yes, minus into cos square alpha minus cos square alpha minus into cos square beta minus cos square beta, because minus into plus minus. Okay, minus into cos square gamma. Yes, minus cos square gamma. What is bracket? Yes, which tends to 1, because the before result. The before the result is cos square alpha plus cos square beta plus cos square gamma equal to 1, where the moon bracket tends to 1. Where the moon bracket tends to 1. Okay, which is equal to 3 minus 1. 3 minus 1 is equal to 2. So which is the result, next result. That is, one can say sine square alpha plus sine square beta plus sine square gamma is equal to 2. Okay. Next, we have one more result. That is, if A vector, comma B vector, comma C vector are coplanar. See, listen. If A vector, comma B vector, comma C vector are coplanar, then, listen. If A vector, comma B vector, comma C vector are coplanar, then any one vector is equal to linear combination of other 2 vectors. If the 3 vectors are said to be coplanar, then any one vector is equal to linear combination of other 2 vectors. Then we can write A vector is equal to, we can write A vector is equal to, A vector is equal to L into B vector plus M into C vector. That's all. And one can write in different way also. See the different definition. If the 3 vectors are said to be coplanar, then any one vector is equal to linear combination of other 2 vectors. And one can write like this also. Suppose B vector is equal to L into A vector plus M into C vector. And one can write like this also. Suppose C vector is equal to L into A vector plus M into B vector. One can write any one. So usually we are considering the first one. First one is best. That's all. Listen, next important concept. If the 3 vectors are said to be coplanar, then any one vector can be rewrite as linear combination of other 2 vectors. That's all. Children, listen. Now exercise 8.2, first topic, first question. Verify whether the following ratios are direction cosines of some vector or not. Here, some ratios given. We want to verify if they are direction cosines of some vector or not. So that is okay. Okay. So come to the topic, direction cosines. We know that cos alpha, comma cos beta, comma cos gamma are the direction cosines. If the given ratios are said to be direction cosines, then it must satisfy, yes, cos square alpha plus cos square beta plus cos square gamma equal to 1. So here, given that cos alpha, comma cos beta, comma cos gamma is equal to 1 by 5, comma 3 by 5, comma 4 by 5. We want to verify if this ratio denotes direction cosines or not. So that is very okay. Now listen, given that cos alpha, comma cos beta, comma cos gamma is equal to, which is equal to 1 by 5, comma 3 by 5, comma 4 by 5. Okay. Now I want to verify the property cos square alpha plus cos square beta plus cos square gamma equal to 1 means the given ratios represent direction cosines. If not equal to 1, then the given ratio are not a direction cosines. So that is very easy. It is very simple, 2 more question. Now cos square alpha plus cos square beta plus cos square gamma Okay, which is equal to? Good. 1 by, where cos alpha equal to 1 by 5. Therefore, 1 by 5 the whole square plus of, yes, 3 by 5 the whole square plus of, yes, 4 by 5 the whole square. Okay, which is equal to? Good. 1 by 25 plus 3 by 5 the whole square equal to? Yes, 9 by 25 plus 4 by 5 the whole square equal to 16 by 25. Okay, next step. Yes, 25 LCM. Okay, 1 into 25, 25. See, 1 time 25, 1 time 25. Therefore, 1 into 1, 1. That is sum of the numerators because same LCM. So, 1 plus 9 plus 16. Okay, which is equal to? Yes, 1 plus 9, 10. 10 plus 16, 26. So, 26 by 25. 26 by 25. Okay. 26 by 25, whether which is equal to 1 or not? Yes. 26 by 25 is not equal to 1. Whose left hand side is cos square alpha plus cos square beta plus cos square gamma. So, cos square alpha plus cos square beta plus cos square gamma, which is not equal to 1. Therefore, 1 by 5, 3 by 5, 4 by 5 are not directs and cosines. Therefore, 1 by 5, 3 by 5, 4 by 5 are not directs and cosines. Are not directs and cosines. Okay. Similarly, we have subdivision 2. So there are 3 subdivisions. Subdivision 1, subdivision 2, subdivision 3, in which subdivision 1 and 2 myself and subdivision 3 left for you as homework. So subdivision 3 left for you homework, and also in this model example also homework. Example plus the third subdivision homework, and the first 2 myself, first one completed. Now come to subdivision 2. Okay, listen. Subdivision 2 is given by cos alpha, similar way, cos alpha, cos beta, cos gamma. Okay, which is equal to? Yes, that is 1 by root 2, 1 by 2, 1 by 2. So which is equal to 1 by root 2, 1 by 2, 1 by 2. Good. Okay, now verification. Verification is very simple. Cos square alpha plus cos square beta plus cos square gamma. Okay, which is equal to? Yes, 1 by root 2 the whole square plus, yes, 1 by 2 the whole square plus, yes, 1 by 2 the whole square. Okay, which is equal to? 1 square equal to 1 by root 2 the whole square. Yes, root and the square cancel, therefore 2 plus 1 by 2 the whole square equal to? Yes, 1 by 4 plus 1 by 2 the whole square equal to? Yes, 1 by 4. Okay, which is equal to? Simplification. Listen, divided by 4, divided by 4 and divided by 2. Can you tell me which is LCM? Yes, LCM equal to 4. Okay, now simplification. Yes, say how many 2's in 4? Yes, there are 2 2's. 2 2's are 4. Therefore, 2 into numerator. 2 into numerator means that is 2 2's are 4. Listen, into 2 into 2. Okay, so therefore 1 2 is 2. Plus, now, how many 4's in 4? 1. Very good. So therefore, into 1, so plus 1. So 1 4 is 4, 1 4 is 4. Therefore, into 1, therefore plus 1. Okay, what is numerator? Yes, 2 plus 1 equal to 4. So 4 by 4. 4 by 4 is equal to? Yes, equal to 1. Because 1 4 is 4, 1 4 is 4. What is left hand side? Therefore, cos square alpha plus cos square beta plus cos square gamma is equal to 1. Listen, first subdivision cos square alpha plus cos square beta plus cos square gamma is not equal to 1. Therefore, the given ratios are not directs and cosines. But now, cos square alpha plus cos square beta plus cos square gamma is equal to 1. Therefore, the given ratios are directs and cosines of some vector. Therefore, 1 by root 2, 1 by 2, 1 by 2. or direction cosines, or direction cosines, or direction cosines. Okay. Now there are three subdivisions. First to myself, first subdivision, second subdivision, and the third subdivision left for your homework. And a similar way in this same model in example also left as homework. Children listen. Now second topic from exercise 8.2. Listen the topic. Find the direction cosines of a vector whose direction ratios are given. Here direction cosines want to find and the direction ratios given. Okay, and there are three subdivisions of that. Subdivision 1, subdivision 2, subdivision 3. In which for myself subdivision 2 and 3 and subdivision 1 left as homework for me. So subdivision 1 homework and its model in example also homework. So 2 and 3 myself. Okay, here given that find the direction cosines of a vector whose direction ratios are, here direction ratios given. So direction ratios are, first step 1, so listen, subdivision 2. Subdivision 2, the direction ratios are, direction ratios are 3, minus 1, 3. The direction ratios given. So which is given. Okay. Direction ratios given. We want to find, yes, direction cosines. Okay. And here direction ratios 3, minus 1, 3. Which means, which is R vector. Okay. Let R vector is equal to 3 into I cap minus 1 into j cap, that is minus j cap plus 3 into k cap. So R vector equal to 3 into I cap minus j cap plus 3 k cap. That's all. So let R vector is equal to 3 into I cap minus 1 into j cap equal to, yes, minus j cap. So minus j cap plus 3 into k cap. Why? Because we are keeping I cap, j cap, k cap. Because y cap means, okay, any idea? Yes, they are unit vectors. Say for example, unit vector of a vector is given by a cap. A cap is equal to a vector divided by modulus a vector. Likewise, here I cap, j cap, here cap denotes unit vector. Okay. Now step 1 ready. Now modulus R vector is equal to, okay. Can you tell me modulus R vector? Yes, modulus R vector is equal to square root of, we know that R vector equal to xi plus yj plus zk, then modulus R vector is equal to square root of x square plus y square plus z square from the basic preparation. Now R vector equal to 3 I cap minus j cap plus 3 k cap. Therefore modulus R vector is equal to, that is magnitude of R vector is equal to square root of sum of the squares of I, j, k coefficients, that is I cap coefficient 3. Therefore 3 the whole square plus of, now yourself, yes, j cap coefficient minus 1. So minus 1 the whole square plus of k cap coefficient 3. Good. 3 the whole square. Okay. Which is equal to square root of. Okay. Now next step yourself. Yes. That is 9 plus 1 plus 3 the whole square. Yes. 9. Which is equal to? Yes. Because 9 plus 1, 10. 10 plus 9 equal to square root of 19. So square root of 19, which is modulus R vector. Again, let R vector equal to 3 I cap minus j cap plus 3 k cap. Therefore modulus R vector is equal to square root of 3 the whole square plus of minus 1 the whole square plus of 3 the whole square. So modulus R vector is ready. Now I want to answer direction cosines. Okay, direction cosines. Direction cosines. Direction cosines is equal to, direction cosines is equal to divide, divide. That's all. Preparation. It is very easy preparation. Direction cosines is equal to, here R vector is equal to 3i minus j cap plus 3k cap. Now write the coefficients in numerator. Here 3, minus 1, 3, which is present in numerator. 3, minus 1, 3. And divided by modulus R vector, modulus R vector, modulus R vector. So direct and cosines is equal to ijk coefficients in numerator divided by its magnitude modulus r vector in denominator. Okay, what is modulus r vector? Yes, modulus r vector equal to square root of 19. So square root of 19 divided by square root of 19 divided by square root of 19. So which is a required directs and cosines. Okay, subdivision 2 is completed. Okay, let us consider now subdivision 3. Yes, now subdivision 3. Subdivision 3, again the same preparation. Here directs and ratios given. Directs and ratios, subdivision 3. Directs and ratios. Directs and ratios. Okay, directs and ratios equal to, yes, 0, 0, 7. Directs and ratios is equal to 0, 0, 7. Similar idea, let r vector equal to yourself. Yes, r vector equal to 0 into I cap plus 0 into j cap plus 7 into k cap. So let r vector is equal to 0 into I cap, 0 into I cap plus 0 into j cap plus 7 into k cap. Good. Now modulus r vector. Modulus r vector is equal to square root of, yes, 0 the whole square plus 0 the whole square plus 7 the whole square. Okay. Now which is equal to square root of 0 square equal to 0, no need. 0 square, yes, 0, no need. 7 square, 49, yes, square root of 49. Square root of 49 equal to, yes, 7. That is modulus r vector equal to 7. Okay. Now I want to find the directs and cosines. Directs and cosines is equal to directs and cosines. Okay. Okay. Can you tell me directs and cosines equal to? Yes. To write before that, divide, divide. Directs and cosines. What I want to write in numerator? Yes. Good. Where listen. Here r vector equal to 0i plus 0j plus 7k, where I cap coefficient is 0, comma, j cap coefficient 0, comma, k cap coefficient 7. Divided by, yes, modulus r vector, modulus r vector, modulus r vector. Modulus r vector equal to 7. Therefore, divided by 7, divided by 7, divided by 7. Now, simplification yourself. There is a further simplification. But the first subdivision, there is no simplification. 3 by root 19, we can't simplify. Minus 1 by root 19, we can't simplify itself. 3 by root 19, we can't simplify itself. But here, 0 by 7 equal to, yes, 0. Because 0 by any number equal to 0. 0 by 7 equal to 0, comma, 0 by 7 equal to 0, comma, 7 by 7 equal to, yes, 1. Therefore, directs and cosines equal to 0, 0, 1. So directs and cosines. Directs and cosines. Directs and cosines is equal to 0, 0, 1. Listen, first subdivision we can prepare mind itself. Okay, can you tell me how to prepare? Yes. Let r vector equal to, yes, yourself. Let r vector equal to I cap plus 2j cap plus 3k cap. Okay. Next step yourself. Very good. Modulus r vector equal to square root of, yes, square root of 1 the whole square plus 2 the whole square plus 3 the whole square. Okay, next step. Which is equal to square root of, yes, 1 plus 4 plus 9. Okay, what is the total? Good, root 14. Because, say, 3 square 9. 9 plus 1, 10. 2 square 4. So, 14. Square root of 14. Therefore, the directs and cosines equal to, yes, very good. See, divide, divide. Now, 1 by root 14, comma, yes, 2 by root 14, comma, very good, 3 by root 14. Therefore, the directs and cosines are 1 by root 14, comma, 2 by root 14, comma, 3 by root 14. Children, listen, subdivision 3. Listen. Subdivision 3 is j cap. Okay. First, I want to rewrite the question. And also, let r vector is equal to, listen. Let r vector is equal to, here I cap absent. Therefore, 0 I cap plus j cap plus 0 k cap. Okay. Now, modulus r vector. Modulus r vector equal to square root of, Yes, modulus r vector equal to 0 the whole square plus j coefficient 1. Therefore, 1 the whole square plus k cap coefficient 0. Therefore, 0 the whole square. Okay, which is equal to square root of 0 plus 1 plus 0. Okay, write it directly. Yes, square root of 0 plus 1 plus 0, which is equal to square root of 1. Square root of 1 is equal to 1. That is modulus r vector. Modulus r vector is equal to 1. Okay. Now I want to answer for two questions. Let us answer direction ratios first, then direction cosines. Okay, now direction ratios. Direction ratios. Okay, can you tell me direction ratios? Yes. If r vector equal to 0 I cap plus j cap plus 0 k cap, therefore the direction ratios are 0, 1, 0. So 0, 1, 0 direction ratios. Now direction cosines. Direction cosines. Direction cosines. Okay. Can you tell me direction cosines? Yes, very good. Direction cosines is equal to divide. Okay, what is the numerator? Yes, 0, 1, 0. That is numerator 0, 1, 0. 0, 1, 0. Denominator? Yes, modulus r vector, modulus r vector, modulus r vector. What is modulus r vector? Modulus r vector equal to 1. So by 1. Okay, simplification. Which is equal to? Yes, 0 by 1, 0. Come on. 1 by 1? Yes, 1. Come on. 0 by 1? Yes, 0 by any number? 0. Therefore, direction cosines. Direction cosines. Therefore, direction cosines equal to 0, 1, 0, which is third subdivision completed. Come to subdivision 5. Okay? This is subdivision 5. In subdivision 5, given question is 3 I cap minus 3 k cap plus 4 j cap. I want to rewrite my question. That is, let r vector is equal to 3 I cap plus 4 j cap minus 3 k cap. So k should be in last. So that is my A. Let r vector is equal to 3 I cap, okay, plus 4 j cap minus 3 k cap. Okay, now here apply yourself. Very good. Modulus r vector. Modulus r vector equal to square root of, yes, sum of the squares of ijk coefficients. Okay, mind itself. 3 the whole square. Very good. 9 plus 4 the whole square. Yes, 16 plus of minus 3 the whole square. Yes, minus 3 the whole square equal to 9 because minus the whole square equal to plus. So plus 9. Okay, which is equal to, now simplification. Yes, 16 plus 9 equal to 25. 25 plus 9 equal to, yes, 34. So square root of 34. That is modulus r vector. Now I want to answer for two questions. First question direction ratios. Next direction cosines. First direction ratios. Direction ratios. Okay. Can you tell me what is the direction ratios? Good. 3, 4, minus 3. Direction ratios 3, 4, minus 3. Okay. Next answer please. Very good. Direction cosines. Direction cosines. Okay. Direction cosines is equal to any idea to write? Yes. Direction cosines. Divide. Okay. What is the numerator? Very good. 3, 4, minus 3. So 3, 4, minus 3. Denominator please. Very good. Modulus r vector. Modulus r vector equal to square root of 34. So divided by square root of 34, divided by square root of 34, divided by square root of 34. Yes, two answers completed. Subdivision 5 completed. Now come to subdivision 6. Yes, subdivision 6 is very simple. Subdivision 6 is given by, let r vector is equal to, can you tell me what is r vector? Yes, r vector equal to I cap, here j absent. Therefore, 0 j cap minus k cap. Let r vector is equal to I cap plus 0 j cap minus k cap. Okay. Can you tell me modulus r vector is equal to square root of? Yes. 1 the whole square equal to 1 plus 0 the whole square equal to 0 plus minus 1 the whole square equal to, yes, very good, 1, which is equal to, yes, root 2. That is modulus r vector is equal to root 2. That is modulus r vector is completed. Okay. Now it's continuation. Now I want to answer, first one is direction ratios. Okay, direction ratios. Direction ratios. Okay. Direction ratios is equal to, good. Direction ratios 1, 0, minus 1. 1, 0, minus 1. Okay. Next step. Direction cosines. Direction cosines. Direction cosines. Good. Direction cosines is equal to, yes, very good. Divide, divide, divide. Okay. What is the numerator? Yes, numerator. Direction, see, which is subdivision sixth one. In subdivision sixth one, direction ratios 1, 0, minus 1. Direction ratios completed. Now direction cosines. What is the numerator? Yes, 1, 0, minus 1. Or 1, 0, minus 1. 1, 0, minus 1. Okay, denominator please. Yes. Modulus r vector, modulus r vector, modulus r vector. What is modulus r vector? Yes, root 2. Modulus r vector equal to divided by root 2, then divided by root 2, then divided by root 2. So subdivision 6 completed. Now listen, there are 6 subdivisions are there. 3 subdivisions myself and 3 subdivisions left for your homework. Similar way, the same model examples left as homework and write homework and send it through WhatsApp. I will tell you where is the mistake.